Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the OR rule of probability. So the reason it's called the OR rule is we're finding the probability of A union B. Remember, we read this as probability of A or B. So to find the probability of A or B, you add the two probabilities together and you subtract the probability of both. So we can illustrate why this works using a Venn diagram. So a Venn diagram looks like this. It has two sets. So the probability of A or B is the probability of being inside the circles. So to find out the probability of being inside the circles, we've got this probability of the first set plus this probability. But notice I've actually shaded this middle bit here twice. That's why I need to subtract it, because it has been double counted. So a good thing about this rule here is, unlike the rule we had for independent events, there's no condition here. This rule always works. The two events don't have to be independent. But it turns out if they are mutually exclusive, then this just drops off. This equals 0, and you can just add the probabilities. So mutually exclusive events are ones that mutually exclude each other. So mutual kind of means the same. Like if you say, you like someone and the feeling is mutual, means they feel the same way. Of course, exclude means like to stop something happening. So mutually exclusive, they stop each other from happening. Another way to look at this, two events are mutually exclusive if they can't both happen at the same time. So for example, you get an A in maths this semester, you get a B in maths this semester. They're mutually exclusive. You can't have both happen at the same time. All right, let's do a couple of questions in which we use the OR rule. So I roll a normal 6-sided die. Calculate the probability that the number I roll is either even or 5. So it turns out these two events are mutually exclusive. If you roll a die, you can't roll a number that's both even and 5, because 5's not even. So when you have two events that are mutually exclusive, the probability either happens, you just add them. So probability even or 5 is just the probability that it's even plus the probability it is 5. You get 4/6, which simplifies to 2/3. You've probably been using this idea without even realizing. Like for example, if there's a 40% chance you get an A this semester and a 30% chance you get a B, there's a 70% chance you get either an A or a B. All right, let's look at a harder question. I randomly pick an integer between and including 1 and 200. Calculate the probability it is either a multiple of 5 or a multiple of 6. So these two events are not mutually exclusive. You can have them happen at the same time. You can easily pick an integer between 1 and 200 that is a multiple of 5 and a multiple of 6 at the same time. For instance, 30 would be one such number. So we're going to use this rule up here. We're going to calculate each of these. So let's let A be the event that it's M for multiple, a multiple of 5. We'll let B be the event that it's multiple of 6. Now, the probability of A and B. Well, if a number is a multiple of 5 and a multiple of 6, it must be a multiple of 30. 30 is the lowest common multiple of these two. So any multiple of 30, 30, 60, 90, 120, etc., is a multiple of both. So the probability here of A or B, multiple of 5 or multiple of 6, is the probability that it's a multiple of 5. So what's that probability? Well, 200 divided 5 is 40, so there are 40 multiples of 5 that are less than or equal to 200. Now, 200 divided by 6 is 33.3 recurring. 33 times 6 is 198. There are 33 multiples of 6 less than or equal to 200. So how many numbers between including 1 and 200 are multiples of both? Well, 200 divided 30 is 6.6 recurring. 30 times 6 is 180. There are 6 multiples of 30 that are less than or equal to 200. Now, all of this is divided by 200 because that is the total number of possibilities. So it's probability of A plus probability of B minus probability of both. So adding that up, we get 67 over 200, or 0.335. That's our final answer. So let's say that A and B are independent with probability A 0.8, probability of B 0.7. We're going to calculate the probability of A or B. So remember, that's the probability of A plus the probability of B, so 0.8 plus 0.7. And now we need to subtract the probability of both. Now note here that if two events are independent, they can't be mutually exclusive. Independent means they don't affect each other, whereas if they're mutually exclusive, well, they do affect each other. They stop each other from happening. So what would be probability of A and B? Well, we learned in a previous lesson that if two events are independent, the probability they both happen is the product of their probabilities. It's just going to be 0.8 times 0.7, which is 0.56. So probability of A or B will be 1.5 minus 0.56, which is 0.94. All right, let's look at this question here. Out of 30 students in a class, 20 play sport, 11 have a job, and 5 neither play sport nor have a job. We're going to calculate probability of S or not J. Probability either they play sport or don't have a job. Now you can use a two-way table or Venn diagram for this question because there are two sets. Set of people who play sports, set who have a job. There's nothing wrong with that. But I showed Venn diagrams and two-way tables on a previous video. So in this one, we're going to solve without a two-way table or Venn diagram. We're just going to use the formula. So the probability that either event happens, we add the probability of the first event and the probability of the second event, and we subtract the probability of both happening. So the probability of S, the probability a student selected at random plays sport, well, there are 20 who play sport out of 30 in total, so it's 20 over 30, or 2/3. So 11 people have a job, that means 19 don't. Probability someone doesn't have a job is 19 over 30. All right, what's the probability of S and not J? That is the probability they play sport and do not have a job. Now, we have no reason to think that these two would be independent, so we can't just go this times this here. So let's figure it out. Well, notice here, 20 plus 11 plus 5 is 36. We have double counted by 6 because there were only 30 students in the class. So there are 6 students who both play sport and have a part-time job. So that means of these 20 who play sport, 6 of them have a job, the other 14 do not have a job. So the probability of S and not J, there are 14 people who play sport and also do not have a job. So we're subtracting 14 over 30. So you can put these numbers straight on your calculator. You get 25 over 30 simplifies to 5 over 6, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.